I'm Jeff Smith, and just to play this sort of beat you game, I did win the Virginia State Science Fair in 1973 building an analog computer.
Wow.
So,
I thought you were going to throw out EDI.
Hopefully.
Uh-oh. I know what I'm saying, I guess.
Okay, so real quickly, QuantumIOT is a systems integrator in the IoT space. I've started up several companies in this arena. 14 years ago, I started a company called Sensor Logic, which was one of the first IoT companies that was purchased by Gemalto. And then I left there and started a company called Ublip that was purchased by Numerex, a public company. Grew it to about 3 million devices and about over $100 million in revenue, public company. And left Numerex and also started a company called Geomoto along the way that still exists. It's a tracking company. And then moved over to Numerex. Was there probably too long, probably 6 years too long, and left about a year and a half ago and started QuantumIOT. And QuantumIOT is really in the getting people unstuck business in the IoT space. And we provide, as you can see, from the bottom side, it's sort of like, I call it Maslow's hierarchy of telemetry needs, where most companies are really at the just get me my data stupid layer and trying to move up to the analytics layer. And so that's our job, frankly, to be able to do that. So devices and sensors, cloud services and connectivity, platform integration applications, and analytics. And so strategy, systems integration, custom design and build, 24/7 support, partnering with folks like Mike that are great folks in the manufacturing, engineering, and services businesses. And so in '74 was my first job programming. I worked for a company called Call a Computer in California, where we had these teletypes we leased for about $1 an hour, and I rewrote Hunkle Wumpus on a HP 1000. If you
acoustical coupler.
Yeah. Tunnels, and so 1982 built a robotic arm that attached to wheelchairs. In '83, I worked on some of the first cell phone technology from Motorola, including the brick, embedded controllers. '87, I worked on a project with the post office for doing handwritten character recognition. In '91, we won the first international flying robot competition. I was a project manager at ETA, a 4.5-foot tall tail sitter device that could fly both like a helicopter and an airplane. And in fact, in my dissertation at UTA, it was called A Robot That Learns How to Fly, because you can do the math as a helicopter. The Osprey is an example of that, and we worked with the guys at Bell Helicopter Tech trying to do that. And then you can do the math as an airplane. It's relatively straightforward. The dynamics were harder. Back then you didn't have accelerometers, and so we actually rewound our own gyros in order to make this puppy fly. And I have some great video. In fact, there's some video of Alan Alda interviewing us. But great video of this device actually transitioning from, and we could fly it indoors, by the way, which ETA didn't particularly like, but it would transition into horizontal flight and fly at over 100 miles an hour. You've got to be careful because it was autonomous, but you need to be able to take it over. So, and autonomous flying, there were 14 microprocessors on board. Wow. I worked at the Superconducting Supercollider, recruited from the Robotics Institute at UTA before they killed that project. And when they did kill that project, I did what everybody else did, started crying. No, I didn't. What I did was I printed 100 T-shirts, and those T-shirts basically had a picture of the magnet delivery shaft that said, "Congress gave Texas the shaft, death of the Super Collider, October 21st, 1993. I started handing them out, and a young lady took a batch of them down to the magnet test lab, came back with a bunch of Jacksons, and I was like, hey, this is profitable. And so that was one of my first adventures. We ended up selling 700 T-shirts. I made $14,000, bought my first router, and started the first ISP in North Texas called OnRamp. But we bought Sesquinet from Rice University, which was the ARPANET at the time. Ended up to be a dominant player. Bought 52 other companies. I was a president for a while until they realized I was dysfunctional as a president and moved into a regional president position. And we eventually sold that company for $5.5 billion to Nippon Telephone and Telegraph. Well, what I'm going to talk about today are a series of case studies that have to do with IoT and sort of this stuck thing, and some of the war stories around some of those. And I'm going to do it quite quickly because there's a lot of expertise in the room, and I think the dialogue would be better. And so if you want to have conversations afterwards to get into some of the details, that's great. But so one of the case studies is a company called Catapult Health, and the healthcare business. Basically what they do is on-site wellness seminars, including blood tests. And part of the problem is, and it's at your, in fact, this morning we started up about 11 different networks on site at companies all around the United States at 5 o'clock this morning, and we'll probably do about 700 evaluations where you walk in and in 45 minutes they do a full blood analysis. That blood analysis goes up to the cloud. You do biometrics, you enter in information in a tablet. That goes up to the cloud. It gets processed in the cloud. There's some analytics that's done automatically there. It produces a report that's then presented in front of a nurse practitioner who's sitting remotely in San Antonio or in San Antonio or Dallas. And then you walk over and do a video conference with that nurse practitioner with a collaborative display of the full diagnostics, and she or he is guided through that process through some intelligence through the analytics in order to provide you some wellness. We have some great information related to Catapult's success within that field, but the challenge in that opportunity, and I brought a few things for you to look at, but the challenge in that is, and this is the answer. So what's the question?
How do you connect to the cloud from anybody's
office? The problem is you go to anybody's office these days and it's completely blocked from the internet. You can't get into their Wi-Fi connectivity, particularly for video or video conferencing. Right. And in many cases, it's in a Faraday cage. You know, you're in a manufacturing facility in the middle of nowhere, in the middle of 20 miles from the middle of nowhere in East Texas. And so what do you do? And so the answer to that problem is one of the types of solutions that you solve relative to the IoT, which is just give me my data stupid. Yep. And the communications is the problem. And so what we did is we basically took 3 radios from Sierra Wireless. Each of those radios has the capability to have 2 different SIMs in it. And you can tell by the colors, they have AT&T, Verizon, and Sprint. And then in the bottom we have a Linksys a router. And so what we did was Linksys made a mistake, and they basically open sourced some of their software accidentally about 6 years ago. It's called OpenWrite. And we basically enhanced the OpenWrite software, taking the ports on the back, which are normally used for LAN ports. We reprogrammed to be WAN ports and then put in a bunch of software in it to automatically, you basically just plug in the device, and it automatically goes up, finds the best network, and dynamically, every few minutes, looks at the access technology that's going on and what the bandwidth is, combining those or using them separately in order to get that layer of connectivity robust so you can get the data up into the cloud. This is the Abaxis. This is actually one of the tools that is used out in the field. It does anywhere between 14 and 40 different blood analytics, and it does it in about 13 minutes. The trouble is that it's stuck on a machine. And so a lot of what we do in IoT, as you guys know, is we're trying to get stuff out of something, and in many cases it's something that, particularly in the healthcare field, is something that's many years old and has R232 port or maybe has an Ethernet port on it. And so the problem is that in much of what we do is we do aftermarket add-ons. I call it the on-to-end strategy. And so by taking devices that are out in the field that are already manufactured and be able to build little gizmos that basically plug into those things, to be able to snap that information off of it and then have a wireless radio that's built into it to be able to send it up to the cloud, to be able to process information is a lot of what we do in this space. The Abaxis, in fact, has an HL7 protocol, which is, and you have to be HIPAA compliant. You think of all of the things that have to do with remote wellness, okay, relative to on-site diagnostics and personal information, privacy, and providing wireless connectivity and security involved with that. It's not a simple problem. In addition to the fact that most of the companies that do that, like Catapult Health, don't and can't retain, because it's a small company, it's a small startup company, about 6 years old, does about $15 million in revenues, and this year will probably do 150,000 to 200,000 assessments in the field, which is fantastic. And it's all paid for by your insurance carrier, so it didn't cost you a dime. at your business. But the problem is that most of the people who work in the company are health practitioners. They're not technologists, and they can't retain those people. And so they use companies like QuantumIOT in order to enhance their current capabilities and move them into what I call real-time and distributed business, which is what our business is all about. I don't call it IoT anymore when I talk. I talk about real-time distributed business because that's really what it is. And we're transforming businesses into that world. And so with this company, we basically then bolt on the device onto the Abaxis. It extracts the information from the Abaxis. It makes it sure that they were HIPAA compliant relative to the transmission of that information up to the cloud, and the analytics are really done in the cloud rather than on the device itself. A second example that I'll give is Studio Movie Grill. How many people have been to Studio Movie Grill? Great place. Brian's a fantastic guy. Brilliant executioner relative to the strategy and an innovator in his own right. But once again, you have a company, although this particular company has, it is a very large company. I call it a robot with 3,000 employees. They have 30 sites across the United States. Very similar problem, though, because initially when they started that business, you basically ran each one like a restaurant as a submarine. And you didn't have to have this connectivity to the outside world. The problem is that when you get into the size and scale that he is, which is the 5th largest in the United States from a movie standpoint, and he also serves meals, as you know, and that's a problem because you basically have 300 theaters and 30 kitchens and 300 restaurants that operate all at the same time, and Friday and Saturday night are just crazy. And you can imagine, the highest cost in that business is really food, right? And so it's food waste. And so what's the one thing that you really need to do relative to that? You need to do prediction. And so he needed to move up from this sort of, just give me my data stick, which is point of sale information on a ticketing system and a food and beverage system, and move it up to the top, which is optimization, very, very quickly, and to be able to do it across 30 theaters that are basically distributed across the United States in a company that's growing basically at 20, 30, 40% per year. How do you do that? How do you change the wheels of a bus as you're going down the road at 40 miles an hour? And so one of the first things that you do is you figure out how to aggregate that information, you get it reliably, and then once you get into that, you can start doing some analytics on it and do some prediction and use those predictive models to be able to send it back to the field so that they can execute relative to kitchen things. But it's more than that, right? Because truly what this experience that he's trying to give to his clients is Disneyland. Okay, and so why is it Disneyland? Well, it's Disneyland because there's all sorts of things that are happening around you that you don't even know about. And that's the best way for it to be, because the success of IoT is when nobody notices. Okay, and that's true about AI also, and how when you combine those two together and you talk about real-time businesses, the true fact about a real-time business is that all kinds of things are going on in the background. And it really is one of those things where you go from manual to automatic to autonomic. And that's what this is all about. And how do you move through those different stages in a business so that you can get the kind of scalable growth that you're looking for. But in the Studio Movie Grill case, it's a very cool problem, because if you think about it, you basically have digital theaters now, right? So there's 10 theaters in a Cineplex, and he has 30 Cineplexes. And each one of those theaters has a movie projector, okay, and it has trailers, or advertisements and trailers, and the movie itself. And you can move that electronically. It actually comes down from satellite first. It sometimes comes over a very, very high-speed internet connection and basically gets put onto a hard drive. And then you basically start selling tickets, either online or right there at the facility, or maybe at another facility. Okay? And so while you're selling those tickets and things like that, you're doing dynamic analysis through stream computing to be able to process, to be able to real-time make decisions about things like, should I move to a bigger theater? Should I move to a smaller theater? Should I make a bunch of food? What scheduling should I do? Who should I put in certain positions? Because if it's a matinee, I want somebody that really knows how to sell ice cream and that's maybe less than 18 years old or 21 years old. If it's a movie like one of the ones that just came out this weekend, it's one where you're going to sell a lot of alcohol, and so you need to make sure that you have a 21-year-old. And there's all kinds of decision making that you need to do in real time. In addition to that, you have things like displays when you walk in. And how much information do I know about the individual? Can I in fact change that display when they're presenting their ticket in order to upsell them from Maker's Mark to Jack Daniels? And if I can do that, and I can prove it back to the vendor, I'll get a script, right? And then we do things like my senior professor at UTA and my PhD, Dr. Kamangar, came in and he helped us do some prototyping of some devices which have infrared cameras on them to be able to know when people are sitting in their seats. Well, if I know when you're sitting in your seat, I know who you are, and I know the last time you purchased, and I know the people that you came with, and I know every movie that you've gone to, I can present trailers and I can present advertising which is specific to you, and I can give an audit to those folks about exactly who that was, the demographic that saw that. And in fact, if I can do facial recognition, I can do things like, oh, I know that they in fact had a response to this particular one, which is either positive or negative. Okay, now you take that back, and one of the things that I wanted to make sure that I did was realize that this business will only be successful if you don't do one-offs. You absolutely need to make sure that there are certain things that you do that are sort of, crank it, move on, cookie maker, right? So what's the similarity and what's the possibility as you move up this hierarchy between Catapult Health and Studio Movie Room? And in fact, anything else that I talked today, like for instance about coolers with two of the largest soft drink manufacturers, and trying to figure out, oh, okay, how do they stock it? What do they stock it with? Where do they stock it? What are the similarities?
Trying to extract actionable insights from data.
That's right. And so the idea of being able to use AI and machine learning and to do classification algorithms and regression algorithms to be able to know, in classification really it's you present a bunch of data and then you basically say, oh, it's one of these, or it's a category I've never seen before. That's the same problem of when at the post office we save $1 billion a year by being able to recognize characters from hand-printed zip codes by 1% additionally at Recognition Equipment Corporation. Okay, so the idea then is that you try to get that data someplace and then get that data to a point where you can process it using some of these great algorithms and some of these cloud-based computing platforms like Watson to be able then to be able to do prediction. Okay, and classification and regression are two prediction type algorithms to be able to know then what this is. And so what's the difference from an AI machine learning standpoint as you move up that hierarchy? The difference is in conventional computing, when we were all punching cards, and the first card punch, we didn't have a card punch when we got our PDP-AD. And so what I used was I had a paper route, and in my paper route I had a punch that had a triangle, a rectangle on it. And so I punched my first cards in Fortran by actually going on the top and the bottom of the cards, and I gave them to my teacher, her last name being Kurzweil. Ever heard that name before? Right, well, she was a unmarried sister of a guy named Ray Kurzweil, and she worked nights, days teaching us how to program computers, and nights she would take those decks, put a rubber band around it, and go run it at the back of the decks that she ran at night in her second job, which was doing computers. But I digress. The idea then is that from a programming standpoint, we went from an input into a program and doing an output to machine learning, where you take input and outputs and you create a program. That's the difference. That's the difference. And so in this case, the question then becomes, what are the inputs and what are the outputs? What's the training set for supervised learning? Because unsupervised learning is a pain in the ass. And so what you really want is a good training set so that you can then go off and be able to do some level of prediction. At Studio Movie Girl, we also built in the background, because it's one of those things where a lot of the stuff that exists, you have to invent it. And so this is a prototype. If you go into the stores, you'll see the big screens and things like that. Well, if you sort of peek behind the screen, I don't suggest you do this, but if you peek behind the screen, what you'll see is basically an industrial Raspberry Pi, okay, with a wireless connectivity or a wired connectivity to be able to connect up to the cloud so that we can actually change that dynamically, and we can do things like taking that same WRT router, clip off the antennas a little bit, and now I'll look at your MAC address and be able to know that you're walking by the machine. Now you got to be able to be careful because Apple iOS spoofs kind of that stuff and things like that, but there's ways that you can move around and do things, at least know how big the queue is at the bar. so that you can respond in real time to be able to do additional services and things like that. So, third one that I wanted to give you an example of, I love this story because this is truly the transformative story of what's going to happen. And this is a little sleepy company in Arlington called ACP International. And you know what they do? They bend metal and paint it. So how is IoT going to help a company that all they do is bend metal and paint it? Well, the bend metal and paint it is they make street signs. And there was a young fellow that was working and not making enough money at a church, and he was the youth director there. And his wife got pregnant, and he decided he needed to have a different job. And so I asked around some of the other parishioners, and one of them was the guy that owns his business and has for 35 years. And he said, hey, how would you like to be a salesperson? Well, he also happened to be somebody that dorked around with Arduinos and started doing some little wireless stuff. And lo and behold, I got introduced to him by the office manager there. And so we basically helped them build 3 prototypes in 6 weeks that are now starting, they're doing production quantities of it in order to bid for little tiny towns. And really the Smart City Initiative, frankly, it's much, much more about smart towns. Because there's a lot more benefit that you're going to get, and you don't have to go through all the business, right, in order to get that. And so what they're doing is they have 3 signs. They have one that basically does ice detection, they have one that does flood detection, and one that does wrong way. And those 3 signs are wirelessly connected, and they get, instead of $750 a sign, and there's also a sign that basically you have one on this side for crossing the crosswalk in front of a school, one on that side, and there's 2 flashing lights and some information that goes back and forth to headquarters to be able to turn those signs on and off during certain times, as you know, and in addition to saving the person from having to just walk across the street. And you know what? What's interesting about it is they go from $750 per sign to $1,500 to $2,500 per sign just by adding that intelligence. Huge gross margins. Intelligent coolers, interesting project, only because I had worked on it in the past. And the interesting part about this is the fact that the problem is this OntoEnd strategy. This problem is the fact that currently there's 6 million coolers out there, 1.5 million in the United States, many of them in very developing countries in tough environments, and all of them with a 7 to 10 year lifetime. Okay, with compressors and condensers and things on them that are basically 1970s technology. So the question, and it only costs $400. So the question is how does IoT play into this space, right? Well, the answer is you have to be very innovative because it has to be extremely low cost. You have to figure out how to do it wirelessly, and you have to figure out what type of value-added ROI that you can get in large corporations that own these things as assets that are basically divisionally oriented, and from a balance sheet and income statement divisionally oriented. And so the problem is you can't do an accumulated ROI. It's not possible. Okay, because each of the division folks are responsible for their own ROI. There's no sort of centralized place that you can get up to be able to do that. And so each one of those, and that's one of the things that sort of you're stuck, right? Because you can't do the ROI that makes everybody go, oh, it's 4-month payoff. No, okay, it's a 16-month payoff because there's 4 of you guys that are working on it all at the same time. And so in this particular project, we became relatively innovative. So for instance, for the folks that are responsible for the machines and their health and wellness, we did some little clip-on transformers and a little device that's in it, which is an industrial Raspberry Pi, common theme, right? And down at the bottom, and you have the ability to basically know when the compressor's running, when the condenser's running, what the power is coming into it in case you're in a third world country and you've got really crappy power, or they decide to unplug the machine so they don't have to, they save on electricity, right? So you also know interesting information like, for instance, a little bit of wireless technology, or just putting a thermocouple in there. Now you've got temperature, you've got humidity. Now you put an accelerometer on the door. Now you know door open, close. And the accelerometer is really 9-degree of freedom accelerometer these days, right? And so now you know the position of the door. You put a magnetometer on there. Oh, heck, it's already in the same chip. So the MEMS technology and the kind of integration that's happening right now from a sensing standpoint, you have to know about in the IoT space so you can take advantage of these things in these types of situations, and do them at a very low cost, and possibly do them with very low power. So you have, you know, a battery that's plugged into this thing that lasts forever. Now, 10, 12 years ago, I remember doing a keynote speech, and I said, you know what? I think lithium ion is going to be the asbestos of the future. And about 10% of the people got it. Because everybody was talking about smart buildings and putting all kinds of sensors in and putting in, you know, wireless transmitters and things like that, and they weren't talking about being able to, you know, grab the energy and harvest the energy off of other things. We were talking about putting in batteries, and I remember how difficult it was building. You know, we had 2,500 square miles of stuff that could kill people at the super collider. I was responsible for life safety systems. Okay, the problem was that a lot of that stuff you had to do wirelessly. It was very, very difficult problem. Some of the things you had to do wired, you had to do on fiber optics, and you had to chase a proton around and cut it across the diameter in order to get there. You know, maybe 500 nanoseconds before the other one, so you can deflect the proton beam, the hadrons, over to a beryllium target, so you didn't have a really bad event. Okay. But most of the time it was really, really boring. Not that boring, but, you know, exciting kind of little wireless type of stuff. And the problem was that you couldn't get rid of a battery.
Right.
Your problem was that you had fire ants. I mean, it's all these things you don't think about. And so everybody goes out and, you know, waves their hands in cotton candy forms because they're trying to think, oh, IoT is going to solve the world's problems and world peace and all this sort of stuff. And you know what? It is. But it's really hard to do. So, lots of different sensors in there. One of the most interesting, and we received a patent for it, and that was we did shelf out. And we did that several years ago, where you basically did it 3 different ways. One was, you remember those little sensors that infrared, where it actually does an angle, and you know, they're on like every 5 to 15-year-old robot kid's toy from Lego. For measuring distance. I took a bunch of those, I put it on the back, and I said, hey, listen, I'm going to measure shelf out in the Walmart in order to figure out what out of stock is. And you know what? Put a little wireless transmitter on it, ship it up to the cloud, and you know, do a prototype with AT&T for Coke. It was very cool. Okay, we took weight sensors and basically put them at the bottom of the pallet, and we made basically an intelligent pallet that knew the weight, knew basically how many 12 packs of Coke that were on that pallet. And you could do inventory reduction. You could look at it, you know, up in and then you could do predictive models about, you know, when they're selling, and you could look at the weather, and you could look at whether NFL was playing in that city, and you look at all this other information and correlate it. It was a very interesting project. And technology moves forward. Several years later, we basically used one of the MEMS technology chips that are available now. It's $2. In fact, here it is right here. You can pass it around. It's a cool little chip, and there's lots of stuff that's coming out. You know what the coolest part about it is basically MEMS technology, which has both the electronics and the mechanics on board. Accelerometer was the first one that used that technology. This one right here does time of flight up to 30 inches with a relatively high resolution, and it costs $2. And so now I have the ability to, in the back, not to be able to use those expensive sharp sensors, right? Now they've basically gone down by a factor of 15 in less than 5 years. Right? And so all of a sudden it opens up all kinds of capability. If you look at your cooler, you're going to look at coolers differently nowadays, because those little plastic things you do, you know, where you open the door, right, and it slides it down when you take one out. Okay, start looking at the back, because I guarantee you relatively soon you're going to start seeing these little measurement devices in the back in order to measure inventory. The problem is okay, you know the inventory, okay, but you don't know what it is. You don't know the planogram information. If you really look at those ROIs, one of the most important ROIs basically that, and I didn't know this, and that's one of the cool parts about the IoT business, is I know more about chickens than anybody should. and it's like, oh, okay, the ROI really has to do with the fact that if they're responsible for the planogram information inside of a Walmart or a Kroger. Okay, so what that means is they get fined if it's out of compliance. Well, there's a hell of an ROI. It's millions of dollars from a finding standpoint. So the question is, it's not about inventory. That's another silo. What is it? It's about planogram. Well, how the hell do you do planogram? Well, remember the accelerometer allowed you to open the door? Well, why don't you put a camera basically on the side of the door with a wide-angle sensor on it? Cameras are cheap these days. So now when you open the door at 45 degrees, you take a picture. Okay, you take a picture from the front. Fantastic. But you can't do inventory that way, right? Because they're all sliding down. So you're like, oh crap, now what do I do? Oh, okay, well, if you look at the back, you can see a little camera right there. So what you do is basically put 2 or 3 cameras in the back. I mean, you can't have the field of view that you have when you open the door, but that's okay. You can solve that problem with multiple cameras. Go back to the patent, that's in fact what we did, was we had all these different sensors in the back, which basically had that, and it was before we thought about really cameras, but the patent is general enough that it basically covers any sensor that's in the back in a field of view problem in order to solve both planogram information and inventory. So, what do you need? Yes?
Just on that last
Yes.
slide, does that also have a view of who's accessing the product?
Well, sort of. You have to be careful because, in fact, I'll get to a slide in a minute where you go, that's a little creepy, okay? And that's the problem. It's the creepiness.
Also answer the question of who the buyer is.
Well, yes, and in fact, if you look at in some of the signage problems, there's a lot of patents out there for this. When you go through the airport in Las Vegas, you know those big kiosks that have those big signs? There's cameras on those, and those cameras are doing real-time diagnostics to figure out what your demographic is in order to do an advertisement within that.
You know, by the way, when we were at Samsung in 2009, we introduced a Coke machine for Coca-Cola, which is the prestige machine with a 42-inch touchscreen. So it also had a camera on the top and it did the facial recognition. So we actually could see the demographics for that and 3G sensor, so we can actually tailor the
And so here's the next step of that, and we filed a patent about 3 months ago, which is basically the there's some great intellectual property out there right now about doing facial recognition. Well, there's also great information about doing voice recognition, clearly, but there's also stress analysis from a voice standpoint, where you call into a call center and they know that you're really frustrated, and so they escalate you. Well, there's also facial stress recognition. So what we in the patent decided was that wouldn't it be interesting in both Catapult Health and Studio Movie Grill, 2 examples, and some other ones, where, you have the capability to basically hear the voice, watch the face, and be able to react to it from a stress situation standpoint. So now the nurse practitioner is going through your biometrics, okay, and asking you questions or doing through depression screening, and they have a little meter that basically is when you get a little stressed out. And so maybe I need to ask a few more questions, so the system basically can move through a different set of questions depending on how you're responding to things like your blood pressure, okay? So, first idea, though, is remember, just give me my data stupid. It's about sensing. It's about devices in the field. It's about wireless connectivity in most cases. It's about being able to use protocols like MQTT and others and be able to get that up to the cloud. What are the problems from a networking standpoint? Let me give you 10 letters, okay? SLA, okay? IPv6, okay? And what were the other 3? I'll think of them in a minute. Here's what's going on, is that software-defined networking is going to be required because of the fact that as you move away from submarine mode to real-time business, you have to have that connectivity. Here's the problem, though, is that as you move towards IPv6 and everything has its own IP address, all of a sudden, and you get away from the whole concept of NAT, and you have the ability to be able to directly address a device, all of a sudden you have a much more different problem from a security standpoint and from a reliability standpoint relative to the network. But then we move up that layer into an ingestion platform. From an ingestion standpoint, most people, and there's 1,200 different platforms that are out there, okay? I won the Battle of the Platforms contest like 4 years in a row when we were at Numerics. And big deal, okay? The fact was that part of the reason the stress that I left was because they didn't see what was coming, which was a train wreck relative to folks that have moved to the cloud much more quickly than anybody ever anticipated and started leveraging other people's infrastructure and didn't necessarily want to be on a little piddly-ass company from an infrastructure standpoint relative to as they moved into industrial IoT with larger enterprise companies. And the small companies didn't have the expertise and be able to do the DevOps and everything else relative to running a real-time business where if your point of sale goes down, you're out of business. It needs to work with a high reliability, SLA, service level agreements, okay? So what's the solution? Well, the solution is to have this high reliability network with the capability to be able to have an ingestion engine and a data lake where all this data goes to, which is in fact really a mashup of microservices rather than a platform that somebody's trying to sell you and get a managed service fee for in order to lock you in so that they can build a recurring revenue business, which I know about, that has a huge amount of value. The fact is you need to commoditize that as quickly as possible. You do it through open source software, and you do it through the capability of things like Docker and other things to be able to do one-button deploys and things like the OpenStack protocols built by my friends down at Rackspace and the consortium to be able to do things like the deployment of those types of mashup of microservices across platforms like Azure and Bluemix and AWS, and in fact dynamically deploy those things and do them in such a way that you can grow them and shrink them at will across those platforms, once again commoditizing that layer. And that's what's going to happen at that layer, and then you move up and you go into the analytics. Important, this is the Network Operations Center that we set up on Walnut Hill. At our offices, we'll be moving to this new office space. We'll make an announcement about that with some other partners that are moving in with us in that space. And you can see up there, there's actually 5 or 6 different companies that are being monitored in real time. We have a backup NOC that's in Costa Rica in order to do 7x24-hour capabilities. This is a very important part of the process. This screen right here, you might notice there's 30 columns. That's because there's 30 theaters. And you see the rows? That's each of the different systems at Studio Movie Grills across the United States. And most of them are green, which is a positive thing, right? But it's things like, you know the little red button you push? Okay? It all goes into the cloud, and all it goes up. We know exactly how long the response time is and whether or not, we go back to a tablet where the manager basically can go redeploy people in order to reduce the time at which it takes in order to get your food. Okay? So each of those different systems that go down there are systems that are real-time now at Studio Movie Grill in order to build a real-time business. And I know I'm running out of time. This is another concept, which is the idea of a satellite NOC. At Catapult Health, we basically not only have a NOC and a backup NOC in Costa Rica, we have a satellite NOC in the Catapult Health facility. This is actually real-time graph using Observium in order to look at one of these things we call TopCat. They're all named after Hanna-Barbera characters. And it's computer science people are just weird. And what it is these are consults with nurse practitioners. So you can see the bumps in bandwidth, and each one of these right here, it's a little easier to see over here, is when a nurse practitioner sits down, a video consultation starts, and so we have real-time systems that are looking and flagging where you might have problems from a connectivity standpoint and a bandwidth standpoint. And then there's some other metrics that go on. These are systems that are actually looking at the ingestion engine, looking at the data lake, looking at the platform, this mashup of microservice for each one of the instances that occur for each of our customers that could also be deployed, by the way, behind their firewall in their own centers. And so you're watching these things and setting up and doing things like automatically creating Slack messages as if it was like a human in order to do escalation and ticket creation and all that kind of stuff. These are some of the other types of metrics that go on there. Just pretty pictures, tablets. And then you worry about ingestion, conditioning, decorating, and classifying information with things like Spark and Storm. Here's the we talked about SD-WANs. That's my creepy picture. That was your question about creepiness. Because what's going on right now, from a personal privacy standpoint and other things, is you have to be very, very careful. Okay, can you imagine what branding damage could happen if there were photographs that were supposed to be of product and it was of a 5-year-old child? Okay, and then someone broke into that and be able to grab that information and publish that information, and tweet about it, and then all of a sudden it's across the world relative to the brand of the most valuable brand in the world. Okay, and so you can't. So you want to know stuck? Okay, stuck is where you do all kinds of brain damage in order to get something working, right? And then all of a sudden you get up to that level in the company, and they ask one really simple question: what's it going to do to our brand? And you don't have an answer. That's the creepy factor. Analytics we talked about, prediction models we talked about different types of learning, characteristics of learning systems, classification and clustering, and regression analysis is really where it's at. In the future, we'll definitely having lots of delivery stuff. But here's the problem. This is another one. This is kind of funny because Brian, who's very innovative, would love to have supplements to be able to get your drinks and beverages a whole lot more quickly from people. You know, they got runners in those things. They're just running drinks back and forth, right? Well, what a perfect example for a little robot, right? Here's the problem was I started looking into it. In fact, I did some consulting for a company that I love down. It's the only company inside the perimeter of Qualcomm Incorporated. It's called Brain Corporation. If you name Brain Corporation, you're either really good or really stupid, okay? Well, like 60% of the people down there have PhDs from the three-letter schools, and you know, these are some of the most brilliant minds in the world. They're doing some really cool stuff on delivery, okay? And I go down there and think, wow, you know, the technology is such to the point where we're going to have pizza delivery to home, you know, walking down, you know, all the kinds of stuff. It's not going to be drones, but because I know a lot about drones, and they, you know, they hurt people, and so, you know, what's the answer? Well, the problem is dim sum. What?
Oh yeah, of course.
The problem is dim sum. You know what I found out? I talked to a guy in Toronto at one of the largest dim sum restaurants in the world that basically does delivery of dim sum through robots. Okay? And did it for a long time and now has backed off on it. You know why? Because the robot goes into the kitchen and what happens? It picks up grease on the wheels. And then it goes into the restaurant. What happens? The grease goes tracks on the carpet. And so now you basically have a restaurant where you have to wash the carpets multiple times a day because of all the grease that's accumulating in the carpets. Has nothing to do with, you know, robotics. It has to do with dim sum. So, you know, what's the future like? I love this picture. It's about augmented things. Okay, so you know, augmented strength, augmented, you know, which is things like, you know, Caterpillar, you know, augmented intelligence, which we're starting to see now with AI and machine learning, things like that. Augmented sensory perception, which you've seen a lot of now. Just, you know, read, you know, some of the interesting books like A Tipping Point is Near and Augmented Reality. One of the really fun things, and that's the last thing I'll talk about, I promise. The really fun things about 10 years ago, we did this thing where, you remember Second Life? Where you could like buy an island or whatever. So I bought an island, okay? And I built on that island a kitchen, okay? And I programmed that island in the kitchen to be able to have a TV screen, okay? And then I took a live camera that was down at my kitchen, okay? And I took that camera and I pointed it at one of those, you know, those little bunnies that have little ears and it has a little nose and it's Wi-Fi connected, okay? So it was a Wi-Fi connected bunny sitting in my kitchen table, okay, in my kitchen with a camera on it, of which the camera is then projecting into Second Life, okay? The TV screen would show the bunny, and I had my avatar walk up and hit a imaginary button, you know, a button inside my Second Life, and the button basically made the ears of the bunny go down in real life, okay? And it was like, I tell you, the cool part about that was that the audience that I talked about that to at a keynote, you know, 12 years ago or so, was that 20% of them had that reaction, okay? And everybody else kind of looked like a dog had heard a noise for the first time. You know, it was like Scooby-Doo. And nowadays you do that 10 years later, and you do that to a millennial, and they go, that's no big deal.
Right.
Okay? That's all I got, no beg for more.
I got a question about, since your previous business, your current business, and your partner businesses are all co-located in the same building. When you move, are they all moving?
Well, I'm moving to the same building.
Okay.
Yeah.
You're like, that whole building is just your business.
No, it's not true. It's not true. But that was true at the InfoMart.
Okay.
You know, when we started OnRamp at the InfoMart, we started in a room so small that Joe and I had to tell each other when we were going to move our chairs. And at the end, we owned 2 floors.
IPv6 has a real problem with IoT as far as most sensors, or many sensors, don't have enough processing power, memory, or capability to handle the entire addressing scheme. So,
Sort of, not really. I mean, these days an STM32 is $2, and you know it has enough capability to be able to do the entire IPv6 stack. I mean, part of it is going to be the sort of layers that have to do with like TLS 1.1 and some of the encryption and that sort of capability. But the reality of that is that those folks are so far ahead of the curve on doing a lot of that encryption basically in hardware rather than software that I'm not worried about it.
Okay, but there are a lot of efforts in like expressive internet and 4D to replace that, right?
Oh, there's one slide that I missed. Yeah. So you said 4G. I wanted to make
No,
sure.
I didn't say 4G.
Oh, okay.
I said 4D.
Oh, okay. Let me do something just because I know a lot of you need to leave. There's one other thing that you need. I did a quick presentation, it's like a 10-minute presentation in Austin about 5G and IoT. Okay, and let me boil it down for you and tell you why this is going to be really important. And why the Verizon announcement several weeks ago, and recent announcement where they basically have two different systems, and one of them they got to upgrade their software, and they think they're going to fix it this weekend, blah, 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 and yeah, it'll get fixed, okay? And they're deploying across every one of their cell sites in the United States, 5G NB-IoT, 5G Cat-M technology, and then the NB-IoT technology. Why is it important? It's important because part of the problem that you run into in the IoT space is this cost. It's the relative cost of getting the information out of the device, okay? And it's both the cost of the device itself plus the amount of cost on the data that comes out. Well, 5G system solves that problem in a big way. And it does it through there's really 4 different things in what's called Release 13. And I was like sticking this in my eyes. I was the chairman of the IoT committee and all this other crap. I mean, I did standards. You'd eat rubber chicken on big round tables with people that are really boring. It was terrible. Then they promoted me, and I was at the UN and had to go to Geneva, which was great, but still, rubber chicken, round tables, same deal. Here's the deal. Cat-M. The silicon complexity is about the silicon complexity of half of a 3G module. Therefore, the cost will be about half of a 3G module, which means we're talking about $6. Okay? Cat-M does a meg up, meg down. Cat-M has incredible capability with the cell tower to be able to coordinate power. And the ability to be able to, when you power up, to already be registered on the HLR. That's really important because the amount of time that you have to spend thinking is a lot less, which means your battery power, and their goal was 7 years on 2 AA's. Okay? Probably make it. Here's the other one, is that with Cat-M technology and narrowband IoT, you'll get to that in a second, basically you have the capability on each cell tower to do, and okay, they missed it by a few, but instead of 50,000 devices, 40,000 devices being tested now. Okay, and walk down any Katy Trail or whatever down here, right? How many cell towers do you see as you're walking? It's like every 100 feet. Okay, so you can imagine that the capacity and the ability to be able to overcome some of the 4G limitations is basically in Release 13 and Release 14. From a power standpoint, from a cost standpoint of the device, from a registration standpoint, from a latency standpoint with Cat-M, you're talking about millisecond latency, which means that you can have a security device which is a door that basically has a processing in the cloud or some sort of fog computing at the edge. Okay, that's going to transform things like crazy. Okay, and having that kind of latency. And then narrowband IoT is basically about half the cost of that and twice the power savings, which means that you're going to see 7 to 10 years on single AA batteries, and you're only transmitting a few times a day, but really, how often do you need to know a lot of this stuff? And we were taking satellite trackers and embedding them, injection molding them into plastic pallets in order to track plastic pallets around the world, and we got 7 years battery life out of this stuff. So, Cat-M, narrowband IoT, be very well aware of the technologies that are happening there. Sorry.
The issue would be the cost, because a carrier might be quite nasty and you would have to pay quite a lot.
Well, so what in Verizon's deal, they've talked about the fact that it'll be less than $1 a month, okay, and
which is still a lot.
Yeah.
No. But that's you know what? I was charging $39.95 for a dial-up connection at 14.4,
Sure.
okay, and 6 years later, Lee came out with his company that was doing $9.95 FlashNet, and then somebody else came out with it for free. Okay, so I'm not worried about the cost curve, frankly. I think that when you have the capability in a switch in a cell site tower to do 40,000 devices, you go do the math on that. The problem, though, is that a lot of people are betting their farm from an IoT perspective on large deployments, and that's not true. Okay, so you got to figure out how to build a business on small deployments and proof of concept deployments and pilot deployments before production deployments that are going to be in the tens of thousands. And I know larger deployments because we had 2.5 million devices at Numerex, and that's a pretty good sized number of devices you're monitoring on a daily basis.
By the way, a dollar a month is not a lot if you're getting a meg. If you compare it to like an LP
Sure, it depends on the application.
Right, it depends on the application. If you're talking about a sensor that's chirping 20 kbytes,
Yeah, it's
okay,
a lot.
It's a lot.
Or something that needs to report once a day, 12 bytes.
Yeah, right. That's a lot of money.
Yeah.
If you're talking about,
Right.
I send a video clip
Of course.
twice a day.
Absolutely. No, I agree. That's the thing. I mean, there ultimately can be no single technology that can do everything.
No,
There can't be.
it all wins. That's the beautiful thing.
Thank you.
So, I went to the IoT Evolution Conference in Florida earlier this year, and I really couldn't get a straight answer from anybody on when the Cat 1M1 radios are going to be cheaper than an LTE radio. It's like the ones that are coming out this year.
Someday.
Yeah, I mean, do you have any idea when? I mean, right now I get a 2G radio for $8 or less, and 5,000 piece quantities. I mean, that's
Right.
that TG's of course going away or going away in pretty much the country. But if I want to get to that with the Cat 1M1 radio, and I'm still looking at $18 or so.
You know why?
Right.
The reason is they're using the same silicon. They're just
Yeah.
buffering it back.
Yeah.
Okay.
So if you look at Sierra Wireless and so look at companies like Sequans, which is now announcing all kinds of things. And I know a couple of board members over there that have talked about what their roadmap is and things like that. I'm very optimistic for the adoption of some of the Cat M1 and Cat M0 technology, relatively quickly. The other thing that's going on, which is really interesting, is the fact that AT&T and Verizon are now subsidizing a lot of these companies in order to move the LTE technology from the higher bandwidth stuff down and be able to sort of promote that market because they want to own. They're a little bit scared, not too much, but a little bit scared of the of some of the waitlist and LoRa type technology.
So 2018, you think I should start
Yeah.
thinking about pricing?
Yeah, 2018, you'll see some production quantities of Cat M1 and M0 at reasonable prices.
And it'll be new silicon at that point.
And at that point, it'll be new silicon rather than basically bastardizing the old stuff.
Right. Cool. You should have ran the whole conference. You were there. Yep.
Oh, come on, another question. You guys want to get
It's
out of here?
officially 9 o'clock. If you need to
Okay.
leave, then feel free
Yeah,
to.
I have-
But he's here for what, another hour or so, right?
Yeah, my son just told me he forgot his water polo stuff, and they have the regional championships tonight, so I need to leave probably around 10.
Okay, for another hour, we've
Yeah.
got him.
And,
So ask questions.
I have some
This is-
case studies here. If you don't want to just go to the web, I have my business cards over here, and thanks very much.
Awesome.